Hello, I'm Professor Julio Rezende, and this my presentation is about assessment of the viability of food cultivation on Mars. Important question is how do the assessment of the viability of food cultivation on Mars? Uh, these are important questions because we need to decide about and also evaluate many different aspects to decide about this issue. And in this case, we are very interested about the cultivation of wheat on Mars because we've based in wheat, the example of wheat, would be important to produce the chapati and also the pizza and pasta. And wheat is a very important element to many kinds of food. Okay. In this case, take the example of wheat. We have some questions like how about to produce wheat on Mars if it's feasible. It's important we compare the wheat with other plants to supply food and prepare meals. Okay, take the example of wheat as I said. The wheat is very important to prepare a lot of different foods and also let the astronauts happy and in a Mars settlement because we can see some studies discussing how the moment of have taste the food and also having the crew together as a good moment to let the bond is stronger. Okay. In this research, we consider many aspects such as water, energy, care, productivity, to compare with the possibility to transport wheat from Earth instead to produce on Mars. Okay. In this case, what is the best decision to take? In this case, the results are discussed in this research. Okay. Uh, we have some questions like what kind of food are more efficient to produce on Mars? What variables are necessary to consider when decide about what food to produce on Mars? And in this case, in terms of we need to think about what kind of food are more efficient. Also, the about the variables. In this case, it was possible to establish a methodology based in some steps. The first step is consult the literature to determine the production per hectare by square meter. In this case, was very interesting. We Brazil is a very great uh, food producer, world food producer, and we found a literature discussing this. Okay. Also, we need to determine the area of production. We can see in the case that will be present in the next slide, we are considering 100 square meters to produce this example of wheat. Okay. Also, it's necessary to look the cycle of the plant determine the quantity of wheat to be produced during a year. A fourth step is determine the amount of calories that the food can generate. The fifth step is visualize the quantity of calories to feed an astronaut. Also determine how many days the 100 square meters with cultivation would supply. In this case, some aspects to consider. We have the production per hectare, also the production per square meter. Okay. In this case, if you have one square meter, how many kilos is possible to produce during the cycle of the plant? In this case, it's also important in the terms of cycles of the plants determine how many days are necessary to this plant grows from a seed to a adult plant. Okay. Some plants, it's possible we have like one harvesting by year, or the plants two harvesting by year. Sometimes other plants three harvestings by year. Okay, it's also important to look the how many kilos for square meter. Okay, by year. Also, in the entire greenhouse, in this case, we'll be proposing like a greenhouse of 100 square meters. Also looking the how many calories generated, and something like this. Also, other elements is we need to look the daily demand to attend the astronauts, and how many days is possible to attend with the food produced in the greenhouse. Also, the how much energy is necessary, how much water, how much oxygen. Okay. Also, it's necessary nutrients for the plants. Some plants will demand more work of the astronauts to development of the plants. Also, we need to look the plants like some plants like wheat. We have is presenting main three parts: the leaves, the seeds, okay, and also the roots. In the case of wheat, there's a only less than half the part of the plant, less than 50% will be consumed by the astronauts to prepare the meal, because the leaves and the roots will be discarded. In this case, if you compare the wheat with other plants like potatoes, the potatoes is a root, and is presenting more than 50% of the as a edible part of the plant to be consumed. And this is very important, because like also if you are considering the onion, great part of the onion is also consumed. And then it's interesting to see in the entire weight of a plant, the part of the plant that would be possible to be consumed, and the part of the plant need to be discarded. And there is a correlation. If for Mars, it's preferable we consider plants that possible to be almost completed edible, or consumed by the astronauts. So this is a very important topic to consider in terms of the choice between one plant and other plant to be cultivated on Mars. Also, this interesting topic also mentioned to some astrobiologists, astrobotanists, is about the types and the size of the roots, also related to this discussion also. Also need to look the aerial aspects like the air temperature, the relative humidity, the lightning, the carbon levels, and there's a lot of parameters to look, okay? And also the root health conditions, if you have good conditions to development of the roots, because if the soil is healthy for the plants, the plants will be presenting a good development, okay, and also a good harvesting process. In this case, we need to look also there's some technologies to support, like the use of artificial intelligence, sensors, and also image learning to support the astronauts in the process of harvesting the plants to be consumed. Okay. Also, we are in this presentation we have mentioned a lot 100 square meters, and why 100 square meters? Because we are considering model design to produce food on Mars. Okay, this model is supposed to be transported aboard of the payload area in a Starship rocket. Okay, designed by Starship, and then will be there's a crane to take these models to outside of the payload area and fix these infrastructures in the Mars soil, okay, Mars surface. And then these are aerial image of the concept of this infrastructure. In this case, this model, this is called permaglass greenhouse model. The permaglass greenhouse model presents 8 meters of diameter. In this case, we have the aquaponics system in the middle, presented 1.5 meters of diameter, also a corridor, and also the 1 meter of permaglass membrane in the outer area. Here is possible to see the other perspective, how would be the inner user of the permaglass model. Also, we have like the fish in the interior area. In this case, it's a aquaponic system because we have the water where the fishes are cultivated, and then the water with nutrients circulates to the grow beds where the plants are growing, and then we have something like this. Okay, this conception, as you can see here. Also, there is other image of the permaglass greenhouse model, as you can see here, and also the permaglass with the representations of the food cultivator in the area. Okay, this permaglass material is a kind of material that permits the lightening to development of the plants, but also retaining the cosmic radiation. Okay, and then we need to look this very carefully, because the cosmic radiation also would bring some problems in terms of genetics of the plants, and we need to take a great care about it. Okay, in this case, if you have 100 square meters cultivated in the permaglass model, these we identified in the case of wheat, 1 square meter in a cycle of 180 days is only possible to produce 400 grams during 6 months. Okay, in this case, during a year, it's possible to have two cycles of this plant. In this case, in the first cycle, producing 400 grams, in the second cycle, producing more 400 grams. In this case, in 1 year, each 1 square meter is possible to produce 800 square meters, less than 1 kilo. In this case, these 100 square meters, if I multiply 800 grams for the 100 meters, I have 80 kilos of wheat. Okay, and then something important to look is if it's better, I transport a model of a big model like this, is 3 meters tall and 80 meters of diameter. It's better I transport a big model like this, or I transport 2 sacks of flour, okay, from earth. Okay, because, and this is very interesting discussion, because maybe it would be better, instead to transport a model, would be more interesting to transport only 2 sacks of wheat for Mars. Okay, and then it's a very important discussion that you need to look, because when we are doing this comparison, also the flour would be also more rich, prepared to have more, presenting more nutrients, also vitamins for the astronauts. Okay, and then in this case, comparing these two situations here, also would be better transport flour, wheat from us to the astronauts, instead to produce wheat on Mars. Okay, in this case, you need to look in this representation. There is a lot of kind of food to be cultivated on Mars, and it's very important we look the possible comparison between many kinds of possible cultures, agricultural experiments to be developed on Mars. And also some aspects to be considered: computer vision, machine learning, some specific elements like macro and micronutrients for supply elements autonomously. Also literature about time expected to produce the vegetables and possible threats in extreme conditions. Also consider the water uh, and nutrients availability. Also in the process of have a greenhouse on Mars, we need to consider the accidents like the water interruption supply, toxins if it's not treated, failures in the temperature control, also lightning problems. Also, you know that Mars presents a very thin atmosphere. Sometimes meteor will be damaging the infrastructures and other very challenging situations. Okay, here we have a concept of some greenhouses that will be connected in Mars surface. Also, the other aspects to observe: high demand of nutrients and energy at the work of astronauts. Okay, we need at least one or two dedicated to greenhouse operation. Also consider the losses about what would be this percentage, because also in the look in the Brazilian experience, there's a lot of losses only in the moment to collect the food, the harvesting process. Maybe this also would be happening also in space. Okay, also need to think more about the risks for crops in space. Also, in this case of the important decision is the question is transport a model. 100 is the permaglass model, or two sacks of 40 kilos to space to supply just 1 year. Okay, uh, but we are considered that the food cultivation on Mars is very important in terms of learning, is operating as a laboratory. Okay, as a conclusion, we need to consider to produce other plants instead wheat, uh, because other plants, maybe like potatoes, onions, would be more efficient in terms of calories generation. Okay, in less demand of water. Also, in this case of this examination of in terms of wheat, it's better to transport flour from earth. Okay, the powder. Okay, thanks so much for your attention, and now I'm open to questions. Thanks so much.